Welcome back. This is third lecture of Uniqueness and Existence Theorem. Picard's uniqueness theorem. We all of us know. In my previous video, I have discussed existence and uniqueness theorem elaborately. By Picard's theorem, we can tell there exists one unique solution. And today, I will see how look like the solution actually. Solution may be two types. One trivial solution and other non-trivial solution. Trivial solution means obviously yx equal to 0 solution, identically 0 solution, this is. And non-trivial solution means yx not equal to 0. Now, there can be three types of solution. One, unique solution. Second, infinitely many solution. Third, no solution. Unique solution can be two types. One type of solution, this is only trivial solution. Another solution, non-trivial solution. And infinitely many solution means exist trivial solution and non-trivial solution. This is meaning of infinitely many solution. And other non-trivial solution. Third, no solution. What is no solution? No solution means neither trivial solution nor non-trivial solution. This is the no solution. That means solution can be three types. One, unique solution. Second, infinitely many solution. Third, no solution. Some example. First example, dy dx equal to y to the power 4 over 3 with the initial condition y0 equal to 0. Consider fxy equal to y to the power 4 over 3. Here del f del y equal to 4 over 3 y to the power 1 over 3. So in this region, since y0 equal to 0, so obviously the region would be such type xy belongs to R such that absolute value of x less than equal to a and absolute value of y less than equal to b. Notice in this region del f del y also continuous function. That means obviously this function is Lipschitz continuous function. That means by existence and uniqueness theorem we can tell the function fxy has a unique solution. I hope all viewers have understood this type of concept easily. Next, I will say how look like the solution. At first consider there exists non-trivial solution. For non-trivial solution, separation variable, the solution would be such type y to the power 1 over 3 equal to 1 over c minus x over 3. And here the condition y0 equal to 0. If we put this condition, then this value would be 0 equal to 1 over c minus 0. That imply obviously c equal to 1 over 0 and 1 over 0 means obviously infinity. That means there exists no non-trivial solution. So, this solution obviously only trivial solution. And notice these trivial solutions obviously satisfy this equation. Here dy dx, obviously dy dx of trivial solution would be 0 and right hand side y to the power 4 over 3. 0 to the power 4 over 3 also equal to 0. That means if we consider trivial solution, then obviously this satisfies this equation. Also y0 equal to 0. Consider here the initial condition y at the point 0 equal to 0. This also satisfies this trivial solution. That means actual solution of this unique solution is only trivial solution. I hope my all viewers have understood this process. Let's see another question. Here the function is fxy equal to y to the power 2 over 3 with the initial condition y1 equal to 0. That means here the region r equal to xy such that x minus 1 less than equal to a and y minus 0 less than equal to b. In this region, notice del f del y is not continuous. So there exists no unique solution. This is we can tell by existence and uniqueness theorem. Then what solution how look like? Notice here initial condition y1 equal to 0. Then we can take here trivial solution, and the trivial solution would be such type yx is identical equal to 0 because this is satisfy this equation dy dx equal to y to the power 2 over 3 because here dy dx of 0 always would be 0 and 0 to the power 2 over 3 this is also 0. So yx equal to 0, this can be solution of this differential equation. This is one solution which is trivial solution. Other solution would be I will get by separation variable. By separation variable, this solution would be such type y equal to x plus c over 3 to the power q. Now let's put the solution initial condition y1 equal to 0. After putting the initial condition, I will get c equal to minus 1. Then the solution would be such type y equal to x minus 1 over 3 to the power q. Therefore, there exists one non-trivial solution and one trivial solution. And I have got this idea a few minutes ago. When there exist infinitely many solutions, then the solution would be such type trivial solution plus non-trivial solution or non-trivial solution. Okay? I hope my all viewers have understood. Means for this differential equation, there exist infinitely many solutions. Say one question which had come in CSIR net exam. The question is y prime equal to 2 square root of y with the initial condition y0 equal to a. Has option 1 unique solution if a less than 0, option 2 no solution if a greater than 0, option 3 infinitely many solution if a equal to 0, option 4 unique solution if a greater than equal to 0. Here obviously fxy equal to 2 square root of y. Then del f del y means y to the power minus half. Since in the question has given the initial condition is y0 equal to a. If we consider a equal to 0, then y0 equal to 0, then in this region, notice the function is del f del y is not continuous. So, in this region, there exists no unique solution. Okay? But if we consider a equal to arbitrary a, then the solution would be by separation method, solution would be such type. Now consider the initial condition y0 equal to a, then this would be a to the power half equal to c. That implies y to the power half equal to x plus square root of a. Now let's see the option. Option A indicate unique solution if a less than 0. If we take a less than 0, then for negative value I will get complex root, and complex root always pairwise exist. So unique solution if a less than 0, this is not possible. So option 1 is a wrong option. No solution if a greater than 0, this is also not possible because always there exists solution. Option 3 indicate infinitely many solution if a equal to 0. If a equal to 0, then one solution is such type. Put the initial condition y0 equal to 0. That means one solution would be y equal to x square, which is non-trivial. Also, if we consider yx equal to identically 0, this is also solution of this equation, because if we consider yx equal to identically 0, this is satisfy dy dx equal to 2 square root of y with the initial condition y0 equal to 0, because dy dx of 0 equal to 0 and 2 square root of y at the point 0, this also value of 0, and so this is satisfy the equation. So yx equal to 0, this is also solution of this differential equation. That means there exists two solutions, one trivial and other non-trivial, y equal to x square. That means since there exist two solutions, trivial and non-trivial, that means this solution is obviously infinitely many solutions. So option 3 is a right option. Infinitely many solution if a equal to 0. Also option 4 is a wrong option. Unique solution if a greater than 0, not only greater than equal to 0. This is also not possible. So option 4 also wrong option. That means only option 3 is a right option. I hope my all viewers have understood this type of question. Okay, over. Now I will see another type of example. Consider ut, which is actually continuous differentiable function taking non-negative value for t greater than 0, which satisfy the equation u prime t equal to 3 ut to the power 2 over 3 with the initial condition u0 equal to 0. That means here the differential equation is such type u prime t equal to 3 u to the power ut to the power 2 over 3 with the initial condition u0 equal to 0. At first I will see how look like the solution. By separation variable I will get u equal to t plus c whole cube. This type of solution exists, and here the initial condition is u0 equal to 0. After putting the initial condition I will get u equal to t cube. This is the non-trivial solution of this initial value problem. Also, since u prime equal to 3 u to the power 2 over 3, notice ut equal to identically 0. This is also solution of this initial value problem, and this solution is actually trivial solution. So since there exists two solution, trivial and non-trivial, obviously that imply this initial value problem has infinitely many solutions. Okay? That means option 1 and option 2, obviously right option. u2 equal to 0 and u2 equal to t cube, this is also right option. And notice ut equal to t cube, this is solution when t equal to 0. When t not equal to 0, then the solution would be such type ut equal to t plus c whole cube. So, notice here the option, how look like the possible solution. When t not equal to 0, then if we take c equal to minus 1, then this is also right option. When t less than 0, greater than 0, less than 1, then this value would be 0, and otherwise t greater than equal to 1, this value equal to t minus 1 whole, means I have taken c equal to minus 1. Similarly, if you consider c equal to 3, this can be also solution. Actually here the question about how can be the solution look like of this differential equation. Obviously this is solution when the initial condition this, but this can be also solution when t not equal to 0. Here the question, which is actual exact solution of this initial value problem, this is not. Here the question, which solution can be possible, how look like the solution. So this 4 option is right option. I hope my all viewers have understood this question easily. Today I will stop here. In my next video, I will also continue this lecture. Okay? Because this topic is very important for competitive exam. I have told you many times. See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.